Welcome. We are currently witnessing a fundamental shift in artificial intelligence architecture. For years, we've been building monolithic models, trying to bake every piece of knowledge directly into the neural network's weights. But that era is ending. Today, we are moving toward modular, file system-based intelligence. We call this the era of agent skills. In this presentation, we'll explore how we are transitioning from giant, static brains to agile agents equipped with plug-and-play procedural knowledge. To understand this shift, we first need to redefine our terms. In the past, we gave agents tools. Think of a tool like a wrench. It's atomic, stateless, and does one simple thing, like a function call. A skill is fundamentally different. It's not just a tool, it's the instruction manual for how to use it. As you can see here, a skill isn't a single line of code. It's a directory. It contains instructions, execution logic, and reference documents. It modifies the agent's context, giving it the know-how to handle complex jobs rather than just executing simple commands. Now, you might be thinking, if a skill is a whole folder of files, won't that overwhelm the AI's context window? The answer is progressive disclosure. We structure skills in 3 layers to save space. Level 1 is metadata. The agent only sees the name and description. This is tiny, about 30 tokens. Level 2 is instructions. Only when the agent decides to use the skill do we load the recipe, the skill.md file. Level 3 is resources. Heavy scripts and documents are loaded only on demand. This architecture allows an agent to have access to thousands of skills while keeping its working memory clean. So, how does the agent find the right skill? This is the decision architecture. It starts with a user query, say, fill out this PDF. A specialized component called the skill router performs a semantic match. It identifies the PDF processing skill and, this is the key moment, injects those specific instructions into the agent's working memory. This dynamic injection is what allows the agent to change its persona and capabilities instantly based on the task at hand. It is critical to distinguish between 2 major standards in this stack, agent skills and the Model Context Protocol, or MCP. Think of it this way, skills are the brain, MCP is the hands. The agent skill layer provides the procedural knowledge, it tells the agent what to do and why. The MCP layer handles the connectivity, it provides the standardized plumbing to actually talk to GitHub, your database, or your file system. They work together, but they serve completely different purposes. Where do these skills come from? We see 4 pathways to acquisition. Top left, human-authored. This is the manual approach, developers writing markdown files. Top right, reinforcement learning, or SAGE. This is where agents learn by doing. Bottom left, autonomous discovery, like cAgent. Agents exploring software to learn it. And finally, compositional learning, dynamically combining old skills to form new ones. Let's double-click on those automated methods, because the results are impressive. On the left, look at SAGE. By using sequential rollout, where an agent learns a skill in task A and reuses it in task B, we reduce the tokens generated by 59%. It's radically more efficient. On the right, we have SEAgent. This agent autonomously builds a world model of an application. By generating its own curriculum, it increased its success rate on unseen apps from 11% to over 34%. The agents are effectively teaching themselves. Where do these skills live? Their natural habitat is the computer use agent, or CUA. This is a complex loop. The agent must perceive the screen through screenshots, ground itself by mapping UI elements to coordinates, reason about the next step, and finally act via keyboard and mouse. Skills sit in that agent core, guiding the reasoning process so the agent doesn't get lost in the interface. Does this architecture actually work? The benchmarks say yes. If you look at the orange bar, Proprietary agents using structured skills are now hitting 72.6% success rates on the OS World benchmark. That is effectively human baseline performance for these specific tasks. Without structured skills, performance drops significantly. The skill is the bridge between a raw LLM and a functional employee. But we have to be realistic about the risks. We analyzed the ecosystem and found that 26.1% of community-contributed skills contain vulnerabilities. Because skills combine natural language with executable code, they are a vector for prompt injection, data exfiltration, and privilege escalation. If you blindly import a skill, you might be handing an attacker the keys to your infrastructure. To solve this, we cannot rely on trust alone. We need a governance framework. We propose a 4-gate validation process for every skill. 1. Static analysis to check code safety. 2. Semantic classification to detect malicious intent. 3. A behavioral sandbox to run the skill in isolation and see what it actually does. 4. And finally, a manifest check. Based on those gates, we assign trust tiers. This is the principle of least privilege applied to AI. Tier 1 skills are unvetted. They can give instructions, but they get zero access to tools. As trust increases, so does capability. Only Tier 4, vendor-certified skills, get full access to execute code and access the network. We ensure that a random community skill can never wipe your database. Looking ahead, we still have work to do. We need to solve cross-platform portability, ensuring a skill written for GPT-4 works on Claude. We need to handle conflict resolution when two skills give opposite advice. And we need automated unit testing for know-how. How do you test if an agent truly understands a concept? In conclusion, agent skills are the new standard for AI utility. Architecturally, they give us file system-based knowledge. Learning is becoming autonomous. Deployment is happening via computer use agents. And security is evolving toward graduated trust tiers. By modularizing intelligence, we are creating a digital analog to standard operating procedures, knowledge that survives personnel turnover and model updates. Thank you.